Hey everyone, welcome back, and thank you for pressing play on what hopes to be another interesting and brief video for Algebra 2. This one is video 24, Roman numerals, pretty nice, right? This one's about 3D graphing, like my little 3D attempts here to draw. Yeah, I don't draw very well, but you can see what I'm trying to do here. So anyways, let's get into it. With 3 dimensions, we have 3 goals for this chapter. The first 2 are just for today in this lesson. So first off, understand graphing and projections in 3 dimensions. So that's something you're going to make sure you know how to do, or at least something you can see happening and visualize it, which shouldn't be too hard to do once you see some examples. Secondly, this is something that will be new for all of you, graphing points and equations in 3 dimensions. So we've been graphing points in x and y's, probably since you were in maybe 6th, 7th grade, something like that. Now we move up. We have x, y, and our newest friend that joins conversation, z. So now we're going to graph points that have 3 dimensions. Think about cubes and spheres and things like that. Real life, if you're going to do a layout or something. Anyone that wants to do engineering in their lifetime of any kind or architecture, you'll get good at this at some point in your life. The last goal is to solve systems of equations in 3 variables, but this one is for next time. So you can escape that for one more day. So here we have an example of what a 3D graph might look like. So notice again, there's 3 dimensions, which means that this graph includes 3 variables. Here's one of the variables right there, temperature. So I actually have no idea what this graph is measuring, but I see there's 3 different things being measured. And time is x, and crispness is z. I have no idea what this is measuring, but there's my citation. This is where it came from. But it's an example of how you see this graph is changing as x, y, and z all change. So we have not just 2 axes, but 3 axes. Here's another one that actually does make more sense. This one here is from a website called 4D.com. This graph's actually in 3D though. So I've got 3 things being measured. I got years. This would be the y-axis. My months, right there. Those are the x-axis. That is the x-axis. And this right here, it cut off when I pasted the photo in. But it's supposed to measure rainfall of a certain area of the world. Again, the picture is on that website here if you want to see it fully. So you see, in 2009. In May, you were pretty high for rainfall that year. In 2008, the highest rainfall was in April. So you can kind of see there's X, and there's Y, and right here, that's Z. So here's one that you might enjoy a little more. This right here is a 3D Yoda figure that was actually printed off of a 3D printer. If you don't know what a 3D printer is, I guarantee you will within a couple of years, because this is probably the next big technology to emerge and really change our lives. Printing Yoda figures is going to change our lives? No, not at all. By the way, this is from this website here, refinedguy.com. This is an article that shows you things you can print with 3D printers, and these are pretty cool. They can print human organs and blood vessels and even guns that actually work. They can print off parts for cars. I mean, it's incredible. Things. So a 2D printer looks at 2 axes, right? X and Y. And so when you have a 2D printer, sorry for that too, you have a piece of paper and you have either a picture or some writing, and your printer just knows okay, I'm just going to copy what's here and put it on paper. A 3D printer, something like this, will actually measure 3 dimensions, so like left and right, up and down, and forward and back, and give you an image like that. So just an example of what you do in real life with this kind of stuff. So let's go on to the math example. So this right here is what I'm so bad at making numbers, a 3D graph looks like in math. So here I have the y-axis, here is the x-axis, and here going up and down is the z-axis. It's weird because x goes left and right normally, but now y actually goes left and right. X goes forward and back, so forward and back, and z goes up and down. And by the way, for y, this is positive, this is negative. For x, forward is positive, and backwards is negative. So forward's positive, backwards negative for y again. Going right was positive, and left was negative. I mix it up. And for z, it should be somewhat obvious. You go up, it's positive. You go down, it's negative. You won't have to memorize that, which direction which one goes. I'll label the graphs for you when we're in class. But that's just a general idea of what the graphs look like. So let's graph a point. Let's say this point right here, 4, -2, 1. So 4 is x, -2 is y, and 1 is z. Think the alphabet. X, y, and z. So again, this is x, this is y, and this is my z. So x is 4. So what I'm going to do then is go forward. So this is forward 4. So I'm going to start right there. I'm just going to mark that point. Then here, that's going to be y is -2, so left 2. So instead of going left 2 over here, I'm going to go left 2 spaces this way. It's weird, I know. But you have to picture this in 3 dimensions. So I'm going left from where I already went forward. So you kind of move one step at a time. Now I'm going to go 1 up. So from here, I'm going to go 1 up, but not there. I'm going to do it here. So right there, this point I'm trying to draw here, that's the point for -2, 1. Okay? So I'm basically forward, left, and up. Let's show one more. How about the point -3, 3, and 0? So what this means is just what I put over here. So this -3, that's x, so it's back 3. So in brown, I'm going to go back 3 and start right there. Back 3 spaces. Now I'm going to go right 3. So I'm going to go this distance here, but not there. I'm going to go from that point. So about that far that way. So I've already went back and right. My z is 0. So like a good dog, stay and don't move. So I'm right there. So this point right here is the point -3, 3, 0. So I've gone backwards, I've gone right, and I haven't gone up or down. So you can kind of picture now that like that point kind of sits there on that flat plane. This point over here in purple is forward, left, and up. The one over here. And let's do one more. Let's do the point. I'll make this up. I'm going to make this up right now. Down here in yellow. And it's more of an orangey yellow, but whatever. -2, 1, -4. So again, -2 is x. Think the alphabet. X, y, z. So y is 1, and -4 is z. So think to yourself right now, how am I moving from the starting point? And I did forget that before. I should have mentioned this before. This point right here in the middle, that's still called the origin. Man, I should have labeled that right from the beginning, so sorry about that. Instead of being 0, 0, it's 0, 0, 0. So that's the point where you always start. Same as graphing points on a normal XY plane. You start at 0, 0, 0 now, right smack dab in the middle. So from the origin, I'm going to move a little bit this way. This x tells you to what? Think about it. You're going to go back 2. So I'm going to keep that same color. I'm going to start right there where I put this point, back 2. This y tells you to go right 1. So from that back 2, I'm going to go right 1. So it's about that far, but I'm going to instead do it here. And then that negative 4 for z. What does that tell you? Not up, of course, because it's negative, but down 4. So again, talking to a dog, right? Down, boy. Down 4. Good dog. So I'm going to go this distance, but not there, instead back here. So I'm going to try to, I don't like that line, I'm going to fix that. I'm going to try and make it about the same as best I can. So something like that. So this point right there, I've gone back, I've gone right, and I've gone down. So if you're an artist and you're good at this kind of stuff, it might be better for you. If you're not an artist, just bear with me. I'm not a great artist either, so I feel your pain. But you can kind of picture this as being backwards, not backwards, but back, right, and down. So it's kind of just, it sucks because you're on a 2D, you're in 2 dimensions on this page right here. This whole page is 2 dimensions, but you've got to visualize those 3 dimensions on this page. So those are points. We also have equations we can graph. They're not going to be lines, but I'll show you that right now. Oh, but before I go on, one more thing. I just did it here at the yellow line. Make sure you show your path. So like that brown line here, the one up here, I start the middle and go this way. So I go, no I don't, forget that. I go back 3, so I'm going backwards here, and then I go right 3, and then I don't move, so I'm stuck right there. The purple one, I went forward 4 spaces, and then I went left 2, and then up 1. Just use some arrows and show your path. That way it kind of helps you picture what you're doing, so you can kind of know where you've moved and where you've gone to. So also, do not forget to show your path. So add that to your notes also, because when you graph in class, I'll expect you to do the same thing. Okay, back to the equations. Here we go. So here's my equation. So again, I'm going to label my axes, x, y, and z, so I know where to graph it. This equation here is 3x minus 4y plus 6z equals 12. To graph this, you have to find intercepts. But I don't mean x and y intercepts, I mean these 3 intercepts. X, y, and again, say hello to our new friend z, our z-intercept as well. So for x-intercepts, it's like finding x-intercepts with 2 variable equations. You have to make make y and z equal to 0. So my equation, these become 0. So it becomes 3x equals 12, x equals 4. That is the x-intercept. What that means is I'm going to plot that point. That point's right there. X-intercept means that y and z are 0. So 4, 0, 0. So now, let's go ahead and find the y-intercept. So for the y-intercept, just make the other 2 letters 0. So we're going to make x and z equal to 0. Because if you're on the y-axis, so like this whole axis right here, that means x and z are 0. Because you're on that line right there. So if I make those 0, what I get is negative 4y equals 12. Don't forget to bring that negative with it, which means that y equals negative 3. So this is your y-intercept. That's the point. X is 0, y is negative 3, and z is 0. So I'm going to mark that point. First I'm going to erase that brown line. I'm going to mark that point at negative 3. So again, it's the left 3 spaces. Okay? So I have my x-intercept and my y-intercept marked. Now I'm going to find the z-intercept. So z-intercept, hopefully you can guess it, make the other 2 letters 0. So make x and y equal to 0. So instead of having this whole equation here, I have 6z equals 12, which means z equals 2. That is my z-intercept. So that's the point where x is 0, y is 0, and z is 2. So again, notice my z's have lines through them. My 2's do not. If I didn't do that, you couldn't tell them apart. My handwriting is terrible. I say it all the time, but it's definitely true. I can admit my faults. So anyways, I'm going to graph that point right there. So what I've done now is I've graphed my 3 intercepts. So that's step 1. Done. Step 2, just connect your lines. We're almost done here. So I'm going to do that now. I'm going to connect. There should be 3 lines to make. That line, and that line. Done. And step 3, I can move a little bit here. So step 3, shade. Shade in between. So I'm going to do this right here. I'm going to it's hard to shade with Edge Creations because you don't have a paint can app. I'm just going to do something like this. So that's good enough for me. If you like things neat, I'm sorry. So this right here is the equation graphed. This is called a plane. This equation right there. Imagine you're taking a piece of paper and just moving it through the air. That's what this is. This plane also extends in other directions, but I'm just showing you part of that plane. So it kind of is leaned a little bit. It's hard to picture here. We'll do more examples in class, but this is the graph of this equation. So imagine what I colored in blue here, just that blue piece of paper going through 3D space. That's what this is. So we're going to do a lot more of this in class, but I advise you, I have a link posted below in the comments, or the comments with the descriptions of the video, with that the 9 things, that are 9 cool things made by 3D printers. The Yoda is one of them, another one's a gun, a couple other things. It's pretty cool. So if you want to see that, you can see it. Totally optional. Otherwise, again guys, thanks for watching this, and I'll see you next time.